Well, hello there, and welcome to the Waco Dam. Today we're going to be doing something very special. We are going to be tracing your drinking water from the lake all the way through to your faucet or toilet and back again. And we're going to be talking about where your water comes from, especially here in Waco. And I'm going to be taking you to lots of special places, letting you talk to special people, all kinds of cool stuff. So you're going to get a lot more than just me today, which I figure is nice and refreshing for you. Let's get started.
Hi, my name is Nora Shell and I work for the City of Waco Water Utilities Department. And today I wanted to show you a little bit about what we do to help clean your water and make it safe for you to drink. Because our number one priority is water protection, water safety, and the overall health of our customers for the City of Waco. Today we're at the Lake Waco Dam, which is the primary source and the start of our drinking water tour today. It drains straight from the Bosque River, and the Bosque River is 1,600 square miles. It's really kind of starts around the vicinity of Stephenville, Texas, which if we got in a car, we'd drive about an hour and a half to get there. And the Bosque River drains into Lake Waco as it goes through. Once it gets here, we know it does have some pollution issues. There's lots of dairy farms up on the upstream from us. And so we're in the process of helping the farmers realize that some of their waste, the cow waste, is contributing to some of our pollution issues. And it's not just them, it's everybody that uses the Bosque River for recreation or part of their business ventures along the way. Once it gets into the lake, it goes under the dam, or through the dam, I should say, through these big pipes, and it goes into the first part of the cleaning process. And as it goes through, then we go through another second cleaning process before it's distributed out for your use. After that, we kind of extend this water tour to what happens to your wastewater. So once you flush the toilet, wash your dishes, garden, do whatever you need to do with your wastewater, where does it go from there? And as the old saying goes, everything can be recycled, and water is one of the ones that we do that with. So hopefully your tour today will focus a little bit more about the water quality issues that we have in the lake and how your water is clean enough for you to safely use and cook with and bathe in and whatever else you can do with your water. But then at the very last, what happens to your wastewater? All that are important functions of the Water Utilities Department for the City of Waco.
Well, all right. We've now moved on to the first place your water goes whenever it's getting filtered. When it comes out of the lake, the first stop is the Dissolved Air Filtration Plant, or DAF Plant. And Waco is one of the few places in the world that has one of these, and we're going to talk here in a few minutes about what makes it so unique. But I want you to realize getting to be here right now with my camera and my lapel mic is a very, very special treat, because this is a very secure location. You see, this is the first step, the first stop in everything that affects our water supply. And so we have to be very careful about what is photographed, what is videoed. So you're only going to get to see certain parts of it here, especially since this video will be accessible to anyone with a URL. And so just to make sure that things are nice and safe, you're only going to be seeing certain key parts. Because if this location were shut down, it could strongly affect your drinking water supply. And that's not good. So we are going to move on now and introduce our speaker, which I'll let him introduce himself to you, and go over all of the highlights of the DAF plant. It's a treat.
Hi, my name is Colton McGarrah. I work at the DAF water plant. DAF is dissolved air flotation. First of all, our water comes from the lake here, Lake Waco. It comes in on a gravity line, feeds in, splits into 2 trains, comes into 8 different cells. Those cells have fast mixers in them where we inject our coagulant, which is a pack of polyaluminum chloride. What that does, the pack has positive ions in it. Our raw water has negative ions. So those stick together into big clumps, which helps it settle out. In a conventional plant here, we do it backwards. So the coagulant is injected into the water. Then the water comes into these big saturators and shakes the water up and down like this, causing tiny air bubbles. Then the air is shot through the bottom of our cells, comes to the top, and all of our dirt, sludge, is raised to the top. We have a large arm that skims it off the top. Then our clean water is then drawn out back through the bottom, then goes into a large basin. So then our ozone is injected into it, which disinfects our water. Then it goes into 2 large settling basins where it is held for storage or to be waited to pump to our 2 large plants, water treatment plants, the conventional plants. Then before it leaves, we inject our free chlorine and our LAS to make chloramines to further disinfect the water, and it lasts longer. The ozone, by the time it leaves here, it is already dissipated out of the water. So every day when I come to work, I come in first, do an overview of the plant, check our SCADA system, make sure everything looks good. Then I start by recording my numbers from the night before, getting my tank levels for each chemical tank with LAS, coagulant, our chlorine, and such. Go through, check outside, make sure there's nothing disrupted or out of order. Then I start by collecting my samples, my raw water sample. I do my samples in here, then start and go down the line. My cell samples from our 8 cells, collect that sample, then go to our 2 settling basins, collect samples from there, which here would technically be our finished water. It is not finished, we call it clarified, before it goes to our 2 treatment plants. Then, when that's finished, I'll go down to our ozone room and check our ozone residuals. And the point is to make sure you have 0 ozone residual left by the time it leaves this plant. Residual meaning the ozone residual is what is left over after everything has been disinfected and ate up. You have dosage, demand, residual. Okay, your dosage is what you're dosing. Your demand is what the water is demanding. So that's what your dosage is based off of. Then whatever's left over afterwards is your residual. Here, unlike chlorine, we don't want any residual left over. Chlorine, we like to have some residual left over in our field system, and into the customer's house to make sure it is maintained and disinfected.
Okay. I realize that understanding the water system can be somewhat complicated, especially if you're not really used to sciencey things or municipal things like this. Think of it like this. The DAF plant is sort of like, well, it is. It's a pre-treatment to the treatment you get before you drink it. So, think of it like this. Have you ever stained your shirt, or if you have kids, or if you've ever been a kid, which if you haven't, wow. But if you've been a kid and you get grass stains all over your pants or all over the knees of your jeans, you realize that if you want to get grass stains out, you have to pre-treat it. Well, just like you may have to put some sort of shout or something on there, then put it in the washer with your Cheer, your Tide, or your Gain, or whatever. The water coming out has different contaminants in it that originate from dairy farms and things like that. And so the more things that are existing in the water, the more you have to treat it to get it out to make everything look as it should. So just like in the case of my jeans that might have grass stains on them, I might have to treat them 1, 2 times, maybe even 3 to get it back to the way it used to be. Water's the same way. And the DAF plant is nothing more than step 1. Here's the water pumped in through a gravity line from Lake Waco into the very beginning of the DAF plant. Notice how the water even mimics the same greenish color as the lake? That's because it hasn't been treated yet. The water is then moved and placed into larger bins. The tanks themselves are numerous. They're all linked together. And it flows through this large area, which appears to be a sidewalk, that begins to inject lots and lots of air. The air causes the various algae and sediments to break up, and all of the heavier things float up to the top, trapped in air bubbles, or pushed up through the buoyancy. The green stuff that you see is referred to as guac, short for guacamole, because it looks like guacamole. This is all the stuff that used to be inside of the water supply, and it is then skimmed off of the top, sort of the same way as if you would, skim the soap off of the top of the dishwater. And all of these things are pre-treated before going to the water treatment plant. Here's a still shot of it. Ugh. From there, the water flows out, and here it's much, much clearer. This is before any ozone is applied or anything. The water itself has already undergone the most serious treatment, or the thing that people used to complain the most about with Waco water, which was the way it tasted, because they were drinking the byproduct of dead algae. Well, the DAF plant removes that. So the water that you see flowing right there has already been treated once, but is significantly better than anything in the late 1990s. Lastly, I will show you a quick picture of the pipe where the ozone is given to it as one last final hurrah before heading off to the treatment plant. I would show you more images. Here's the ozone. But for homeland security reasons, I choose not to.
My name is Daniel Ives. I'm the program manager here at the City of Waco under the Water Treatment Division. We're here at Mount Carmel Water Treatment, Conventional Water Treatment Plant, one of 3 that we have here in Waco. We've seen the DAF Water Treatment Plant, the dissolved air flotation, and now we have pumped the water from the pre-treatment DAF plant to here at Mount Carmel, one of 2 of the conventional plants. Because of the DAF, the water has reached us a lot more clear than what the lake would yield to us, as far as the clarification part and the disinfection of the ozone. When the water reaches here at the Mount Carmel, we will then treat it again with a disinfection and run it through these long basins where we slow the water down. And in the conventional treatment process, we would let the suspended solids begin to settle down on the bottom, and we'll take the clear water off on top. After that process of the clarification, we here at Mount Carmel will have 16 filters in the back that have just been rehabbed, and the filters are a mimic of what the Earth's soil is doing. So we're traveling water downwards through a anthracite cap, which is much just like a coal material, fine coal, and then through sand, and then through a filter block where the clean water will then go out on the effluent side of the filter. At that point, depending on the pH, we will then increase it back up because chlorine, ozone, and some of your coagulants will want to try and reduce your pH, and so we will add a chemical called caustic soda, which will then bring the water pH back up to a stable position and ready to be shipped out. One other process that we do add is we add fluoride, a very small amount of fluoride to the water for the health of the public. Depending on the flow and the demand of the system will determine how long this water will stay in these long basins. Higher demand, our flow is higher, and so then the detention time, the amount of time that does stay in the basins, will then reduce, and then vice versa at lower flows. Higher demands are usually in the spring and summertime, and lower demands in wintertime. Less usage for irrigation and whatnot.
The very first thing that I want you to notice is how blue that water is. This is the same place, the same tanks, that before the DAF plant, there would have been anywhere from 2 to 6 feet worth of sediment just sitting at the bottom that would have been algae, dirt, other random things coming out of Lake Waco. Instead, it looks like a beautiful blue swimming pool. You can even see the paddle wheels. They're not even dirty. And to give you a perspective of how deep these tanks are, this one was being cleaned at the time that I was there. It gives you a great perspective on just how deep they really are. And of course, the one next to it was still in use, so I really lucked out. From here, the water is pumped over to the opposite side of the plant where it's run through anthracite and sand and some other types of filters, as was discussed earlier. And this is really one of the last stops before they're treated with other types of chemicals. And the chemicals like fluoride, maybe some chlorine. Here's a video to show you just how big the plants are, how many thousands of gallons can be pumped into one. These charcoal filters or coal filters like anthracite are, I remember when I was a kid, my fish tank, I had an aquarium, and my aquarium had a similar type of filter in there that would keep the water clean. This was one that had just been pumped in and hadn't had time to be cleaned out yet. Even though it looks somewhat dirty to you, considering the fact that it had guacamole when I first started this process, by the time it gets through there, it'll end up becoming drinking water. It's just miraculous. And I include this next picture of the control room because I think it looks cool. All of the water is tested and goes through a series of pH and other types of elements that it's tested for, many of which I don't include here for homeland security reasons, and then is sent to a holding tank which sits directly under this grassy section. This is where it's held onto before it's pumped out to water towers or the city pipeline, and eventually your faucet. With our tour and show you some examples. Something like that. Or actually, let me re-record it and not use the term terrorist.